Our third lesson in the Logic and Reasoning unit deals with conditional statements. We use conditional statements all the time in real life. If you eat your broccoli, then you may have dessert tonight. That's a conditional statement. Our essential question today is, how do I write conditional statements? In mathematics, we have 5 types of conditional statements that we work with on a regular basis. In this lesson, we're going to look at 4 of those types of conditional statements. A conditional statement is a statement that can be written in if-then form. So going back to the broccoli example, if I eat my broccoli, then I may have dessert. The symbolic form for this is a lowercase p with an arrow and a lowercase q. We read this, if p, then q. The hypothesis is the phrase immediately following the word if, and the conclusion is the phrase immediately following the word then. Okay, hypothesis and conclusion, along with conditional statement, are 3 words you need to make note cards for. So let's look at this example. If you live in Nashville, then you live in Tennessee. The hypothesis comes after the word if, so it's going to be you live in Nashville. The conclusion is going to come after the word then, you live in Tennessee. Do not include the words if or then when you're naming the hypothesis and the conclusion. Okay, we leave those 2 words out when we identify those 2 pieces of the conditional. The second type of conditional statement we're going to talk about is called the inverse. And the inverse is formed by negating the hypothesis and the conclusion. You saw the idea of negation in the last lesson when we were doing compound statements. The symbolic form would be not P, then not Q. Okay, using the tilde as our negation symbol. So our example, our conditional is if you live in Nashville, then you live in Tennessee. I need to negate this. So if you don't live in Nashville, then you don't live in Tennessee. The third type of conditional statement we're going to talk about is called the converse. The converse is formed by switching the hypothesis and the conclusion. Symbolically, we say if Q, then P. So sticking with the same example, if you live in Nashville, then you live in Tennessee. Let's switch this. If you live in Tennessee, then you live in Nashville. The fourth type of conditional statement we're going to talk about is the contrapositive. This is formed by switching and negating the hypothesis and the conclusion. So this will be not Q, then not P. Same example again. If you live in Nashville, then you live in Tennessee. So I need to switch and negate. If you don't live in Tennessee, then you don't live in Nashville. Okay, let's back up to the previous page for a moment. Let's look at the conditional statement we have. If you live in Tennessee, if you live in Nashville, then you live in Tennessee. Is this true or false? Okay, our truth value for this is true. Nashville is in Tennessee. Let's look at our inverse. If you don't live in Nashville, then you don't live in Tennessee. True or false? Truth value here is false, right? There are other towns and cities in Tennessee other than Nashville. Our converse, if you live in Tennessee, then you live in Nashville. Another false, there are other towns and cities in Tennessee. And finally, our contrapositive, if you don't live in Tennessee, then you don't live in Nashville. True. So this brings us to something that's really interesting, and I'm going to write it here, and it's the idea of being logically equivalent. To be logically equivalent means you have the same truth value. If we look at our conditional statement, inverse, converse, and contrapositive, right? Our conditional statement and our contrapositive were both true. Our inverse and our converse were both false. So we say that the conditional and the contrapositive are logically equivalent. We also say the inverse and converse are logically equivalent. This is always true. Okay? If your conditional is true, your contrapositive has to be true. If your conditional is false, your contrapositive has to be false. They are logically equivalent to each other. They have the same truth value. So now let's take a look at some different conditional statements. We're going to write the following as a conditional statement, and then we will highlight the hypothesis in one color and the conclusion in another. So an obtuse angle has a measure greater than 90 degrees. If an angle is obtuse, then its measure is greater than 90 degrees. Make sure you have a capital letter at the beginning, a comma after your hypothesis, and a period at the end. So our hypothesis comes after the word if. In this case, it's an angle is obtuse. And our conclusion comes after the word then. Its measure is greater than 90 degrees. Try the second example on your own. Pause the video. All right, check your work here. On the next page, give number 3 a try. Pause your video. Okay, check your work. Now, let's take a look at writing the inverse, converse, and contrapositive of conditional statements and determining the truth value, providing a counterexample, of course, if our truth value is false. If it is Saturday, then there is no school. My truth value here is true. Thank goodness. I like my weekends. So, P is it is Saturday. Q is there is no school. Saturday, there is no school. So inverse is not P, then not Q. So if it is not Saturday, then there isn't school. If it isn't Saturday, then there isn't school. The truth value here is false. What about Sundays? Right? We have a 2-day weekend. There's no school on Sunday. Now this tells me, as I'm looking at my converse and the fact that the inverse and the converse are logically equivalent, right? Logically equivalent. This converse had better come out false also. Let's see if that's going to happen. Now the converse is formed by switching. So that is if Q, then P. So if there is no school, then it is Saturday. Okay, this is definitely false. Again, we could use Sunday as our example. We could also use holidays as our example. Now finally, we're going to have the contrapositive. And again, my conditional statement and my contrapositive are logically equivalent to each other. The conditional statement was true. That means this contrapositive had better come out to be true. Let's check it out and see if it happens. So with the contrapositive, we switch and negate. Not Q, then not P. So let's see here. If there is school, started to spell school wrong. Then it isn't Saturday. True. We don't go to school on Saturdays, Monday through Friday. Get a day off. All right. I want you to try number 2 on your own. Pause the video, please. All right, let's take a minute to check this one. The truth value of my conditional statement was true. And I did a little scratch work at the side to play with it and make sure, multiplying 2 odd numbers together and making sure my product was odd. Then I looked at the inverse, not P, then not Q. And again, I played with some numbers to the side to find out that the truth value is true. If the product of 2 numbers isn't odd, or if the product of 2 numbers is even, then both numbers aren't odd. The converse, if 2 numbers are odd, then their product is odd, was true. And the contrapositive, if 2 numbers aren't odd, then their product isn't odd, was also true. This kind of statement where all 4 basic types of conditional statements are true has a very special name, and we'll do that in the next lesson. It's called biconditional. Let's look at one more example. I want you to try number 3 on your own. Pause your video. Alrighty, let's check these real quick. My conditional, if P then Q, was a true statement. I like 25-degree temperature, especially if there's a little precipitation on the ground. We might get a delay or even a snow day. The inverse is false, however, right? There are other temperatures other than 25 degrees that are also below freezing. The converse was also false. Any temperature below 32 degrees Fahrenheit is freezing. It doesn't have to be 25 degrees. And for our contrapositive, it's true. If you're not below freezing, you can't possibly be 25 degrees Fahrenheit. So at this point, I want you to write a summary of the lesson. You should be sure to include the conditional statement, inverse, converse, contrapositive. You should also include the idea of logically equivalent, and make sure you include the symbolic notation.